So ngola mnesambili lama programmable logic controllers kulaba part where you design your logic, and it comes to a point where you have to simulate. Okay, simulate in the sense that you want to see of your circuit mwapanga of your ibomba when you've designed your programmable logic control system, or if you're using things like Automation Studio, you've wired your electrical control schematic to mirror an actual physical copy. Okay, like by copy I mean namkwata drawing as a reference drawing, and that depicts the way the system is wired. Okay, now Automation Studio will allow you to simulate that purely electrical control diagram so that you are better able to understand how it works. Okay, so in under an hour I'm hopefully going to show you just AMA software. I think let's see, Kepware, there's Automation Studio, Net2PLCsim, Vmware. Okay, I'm really going to just tell you about AMA softwares RD4 and how you can use them to your benefit. Okay, so here we go. First off, I'm going to tell you about VMware. Okay, now VMware is essentially just a software which allows you to mount, or rather create, virtual machines on your physical device. By this I mean that in VMware Workstation, I can choose to install things like Windows XP, Windows 10, Windows 11 without having to disturb my physical hardware. Okay, so this would just allow me to install whatever software I want. But the only disadvantage I find with this is, like, if your computer is not too strong, or if you don't have enough RAM, the only thing you can run off these VMware Workstation virtual machines is maybe just those non-processor intensive applications. Okay, I hope you know what I mean by that. Anyway, that's not the point of why I'm showing you about VMware. The reason I'm showing you about VMware is because of what it brings to my computer, or to my laptop rather. Okay, I'm going to go into network and sharing center, and then I'm going to look for change adapter settings. In here, we're just going to look at two adapters. Okay, padi ibalela and that VMware network adapter VMnet1, kwabane ibale about VMware network adapter VMnet 8, right? Clearly VMware, right? And I've just told you about VMware Workstation. So these two adapters are installed when you just basically install the VMware Workstation on your laptop or your computer. Then these are installed. Okay, now my interest is just VMnet 1. Okay, I'm going to look at the properties and then come to where it says Internet Protocol version 4 TCP/IPv4, and then I'm going to go to properties. Now the reason we've come here is that there are two ways we can get the IP addresses with respect to VMnet 1. Okay, one of which is to obtain the IP addresses automatically, which is what we don't want. Okay, so we choose the second mode, which is to use the following IP addresses, and I've already specified the IP address on there for Kubomfi. In this particular case is 192.168.44.1. Okay, you need to remember this, is very important. Now, knowing that I'm using an adapter, which is a consequence of having VMware Workstation installed on my laptop, if you're going to go through this route, I would advise that you install VMware Workstation and you specify the IP address that you want to use. You can choose anything, but 44.1 is just my preference. We're going to open the semantic manager, right? And then we're going to create a project. So what we're going to do is close. Then we're going to create a new project, and then this project I'm just going to call it project name. I'm going to call it plant 007. You can call this anything you want, but in this particular case I'm just going to call it plant 07. Okay, I'm going to say okay, and then On the right pane, we're going to insert an object, which is a SIMATIC 300 station. Double click, hardware. In here, of course, we're going to insert an object, which is going to be a rack or rail if you want. 300, we need to install a rail. And then having done this, we need to go in the right section under SIMATIC 300. We need a CPU, okay? Now, for what we are going to do, I need a CPU which is Profinet capable or Ethernet capable if you want, okay? So I'm going to choose the CPU 315 2PN DP, right? I'm going to pick any one of these. It really doesn't matter which. Kaidita to create hardware, so anything will work. I'm being asked to create a network. In this particular case, an Ethernet network, okay? In this interface, okay, in this Ethernet interface, the only interesting bit, among other things, is the designated IP address, which is 192.168.0.1. I'm not going to change this, okay? I'm just going to leave it as default, and then I'm going to choose to create an Ethernet network. I won't change the name. I'll leave it as Ethernet 1. I'll just say okay, and then okay, right? I'm not touching anything, okay? I'm not really going to touch anything. I'm just going to say compile, save and compile, okay? Save and compile. When that is done, we're out of here. And then you can also choose to see that the network has been properly configured. So we click on this network toggle button up top, okay? It opens, and then it shows us the configured networks. The only thing we need to do is create the MPI network, then compile and check, or save and compile again. Compile and check everything, and then that's just about it. We close this, close not this one, but let's explore the project structure. And then I'm not going to insert another function so that we compartmentalize or rather sectionalize the logic, okay? I'm just going to use OB1 because there's something specific we're looking at, okay? I'm not going to bother with the symbolic name. I'm just going to use it as is, okay? Then I'm going to use OpenOB1. Come on, OpenOB1. And then we're going to just create a simple sample logic, a sample logic, okay? Now your logic, okay? Normally open, output coil, then an O branch across the first normally open contact. And then we're going to assign addresses. I'm going to use bit memory addresses, okay? Memory bit 10.0, okay? Then memory bit 20.0, okay? Then memory bit 10.1, like so. Then memory bit 20.0, okay? Like so. Like this, okay? Then we're going to create symbolic names. So edit symbol. So memory bit address 10.0, we're just going to say start, okay? Then memory bit address 10.1, we're going to say stop. Memory bit address 20.0, we're going to say run, okay? Like so. And then we're going to say apply, then close, okay? So this is what we have, okay? Now to just check that the logic is okay, so we're going to start the PLCsim, like so. I'm going to pin it, and then of course you notice that what's in the interface, as into which communication profile are we going to use, it's saying PLCsim TCP/IP, okay? We're going to leave it as is because in the network configuration we have an Ethernet protocol configured, so there we have it, TCP/IP, okay? I'm just going to download this project to the PLCsim. We're going to once again open OB1, and then we're going to monitor. Okay, first we need to be in running P, monitor, which seems to be okay. And then for the normally open stop, we're going to modify to 1, okay? Then to start, or rather energize the output coil, we need to toggle the start, okay? So modify to 1, modify to 0. So you see that this is actually functional. Okay, then to stop this, we just need to say modify to 0, like this. Okay, so this we've done before. There's really nothing strange. Okay, so I'm going to put this away. Should I minimize? Okay, let's just minimize. And then now comes the next interesting bit. We have the Net2PLCsim, which is the next, or rather, it is the next software I'm telling you about. Okay, so we're going to open the Net2PLCsim. It's going to be asking you, before you can use Net2PLCsim, you have to stop the program which uses the port, which uses this port. It seems to be the Semantic S7 DOS help service, blah blah blah. If you have started Net2PLCsim with administrative rights, the service could automatically be stopped, which reminds me I need to run this as an admin. Okay, so run as an administrator. We've read through this, so I'm just going to say okay. Hopefully I won't get into trouble with, okay, I won't get into trouble with the PLCsim, because usually I've noticed that okay, this is what I was afraid of. So let's do this. Hopefully won't get unable to. Okay, so the only thing I can do is I can close this, which I suspect you're going to have the same problem with this. So it's better you open the Net2PLCsim first. Okay, we already have project 7. Okay, so let's get the PLCsim up and running again. Okay, come on. Okay, like so, and then let's pin it. Then let's download our project to the simulator. Okay, so running P, and then OB1. Let's monitor this. Okay, so it's healthy now. So the key takeaway from this is you need to open Net2PLCsim first. Okay, open Net2PLCsim, then you open the Semantic Step7. Okay, because apparently they use the same port. Okay, so once Net2PLCsim is opened, we're going to have to add a station. Okay, so this station I'm going to call plant. What's this? Plant? No, we need plant. We're going to call plant 007, same as the Step7 project. Okay, now where it says network IP address, okay, remember I showed you that when I installed VMware Workstation, it also installed its own network adapter, okay, which was 44.1. okay, 192.168.44.1. so this is the one I want to use. Okay, and then where it says PLCsim IP address, the PLCsim IP address is 01.192.168.01, which I hope you do remember. Okay, which I hope you do remember. I hope you can see it from here. Okay, can we see it? Maybe you can just see it from down here. So the IP address is 192.168.01. okay, so that's the IP address for the PLCsim IP address. Okay, so once we click on these 3 buttons, okay, on this button with 3 dots or whatever, you're going to see that the network reachable PLCsim PLC is 192.168.01. okay, so we're going to select this, then just say okay. And then the only other point of note, apabalela that PLCsim rack and slot nabalanda okutila for an S7300 PLC, the rack, okay, the rack will be selected to be in position 0. Okay, and then the slot for the PLC CPU will be in slot 2, right? So which accounts for 0 and 2. So that you can see from here. Okay, you notice that the PLC CPU is actually in slot 2 here, okay, and then this is actually taken as rack 0 there, okay. So that's just about it. That's what this is just trying to tell you. So we just say okay, and then at this point we can just click on start server, okay. So we don't really have to look at this going beyond this point. But now at this point, the only thing that Net2PLCsim is going to help us do is going to allow us to pull the data from Step7, okay, from this semantic manager project, so that we're able to pull the data into the OPC server, okay, which is going to be provided by KepserverEX, which in this case I have version 6, okay. So the only thing we need to do is talk about KepserverEX, okay. Now when you install KepserverEX, now KepserverEX, you can just download it. It's free for, I think it runs continuously for an hour or so, okay. Then you just need to reset, okay, if you don't have the product key. So I'm going to right click here, and then, or is it left click, then right click, and then go to, I think, OPC UI configuration, okay. What's this now? Is it administrator? Because I set this up when I was installing. You may also have something different, okay. So the only interesting point is you need to ensure that your server endpoint, which is this one, is enabled, okay. Yours may be different, but it will also bear the name for your computer, okay. So you need to ensure that this is enabled, okay. I think that's the only thing you need to do in this interface. Then the only other thing you need to pay attention to is settings. Yes. Administrator, okay. Administrator. Okay. So the other thing, when you come into the KepserverEX settings, you need to ensure that the runtime process, okay, is set to interactive. If you don't set this to interactive, you may have issues trying to get what we are trying to do to work, okay. So you need to come in here, ensure that the runtime process is interactive, okay. So having done this, we now open the configuration, okay. We open the configuration. You can open it by way of doing this, okay, or you can just double click on this, okay, on this shortcut here. So when this does open, where it says connectivity, I'm going to right click, say new channel, and then the channel I want to create is what? The channel I want to create is a Siemens TCP/IP Ethernet, okay. So I'm going to come down to Siemens TCP/IP Ethernet, okay, and then this channel we're going to call plant 007. Then next, the network adapter, we can choose the same one, the 192.168.44.1, okay. Next, optimization method, write only latest values for all tags. I want to write all values for all tags, okay. Floating point values, choose how to send invalid floating point numbers to the client. I'm going to leave this as default. Then I won't change anything. There's nothing really to change anyway, so finish. And then thereafter, okay, before I do anything else, I did this previously. I was using the same IP address, so it's in my best interest to delete this other one because it's using the same IP address, the one that we're using, okay. So under plan 007, we're going to create a device, and then I'm going to call this device 1, okay. Then next, The type of CPU that we're working with is a Siemens S7300. Okay, so that's what we choose. Next, the ID, same as before, 192.168.44.1. Okay. Scan mode, specify the method for determining how often tags in the device are scanned. Scan mode, respect client specified scan rate. I want my own scan rate. So request all data scan rate. I'm going to go with 50 milliseconds. Okay. And then default port. Okay. Now this is the reason why we get an attitude out of step 7 when we try to run the Net2PLCsim, okay, when it's running already, because apparently they all use the port 102. Okay, so we're not changing anything here. Okay, we just go next, next, and then we've been asked to say, let's see, select the source for tag import type step 7 project file. Okay, we'll leave it as default. Locate and select the Siemens step 7 project file from which to import tags. Okay, I don't really think anyway. So we need to just click on this button with the 3 dots here. Now you'll be saying, okay, how do I know which file to pick? Here it's step 7 project S7P. So S7P is this one here. Okay, I don't want to do anything with this part. It doesn't affect anything. So next, then finish. Okay, so when this is done, the only other thing is to create AMA tags in this right section here. Okay, so click to add a static tag. I want to add a tag, and then the tag is okay, let's say start, yes, and then the address is IX 0.0. Oh no, we're using memory bit, so memory bit 10.0. okay, and then of course if I didn't want to go back and forth, I can just copy this, paste it there, properties, then do a rename. Okay, so the next tag is stop, address memory bit 10.1, it's boolean. Okay, client access is read write, which is true, then that is done. Then the last one should be run. Okay, the last tag should be run. Address, I think it was 20.0. okay, like so. So this is done, right? So having done this, okay, we're going to select all these tags. Okay, runtime connect. Maybe we need to do that because we disconnected. Okay, save changes. What is it that you're asking? Okay, just one. So we save it there, and then we need to run this. Okay, select, then quick client. Okay, so we get this. Then we need to look for our project, which is plan 007 dev 1. You see that our interest are in these 3 tags. Okay, the quality is actually saying that the quality is good, which is just to say that our KEP server, okay, as an OPC server, has got access to the tags that we created in what? The tags that we created in step 7. Okay, so these particular tags, right? So let me just put them side by side so that you see what I'm talking about. So this is what is happening here. Okay, so I'm going to select these 3, synchronous to write. Okay, so the first one I'll need to set is the stop, which is memory bit 10.1. so stop, I need to set this to a value of 1. So you see that this actually gets a true state, right? And then that's the stop, true state, because I'm able to set it within the server. Okay, so 0, then 1. Okay, so to start this, I'm going to say get a true state for the start. So apply, then 0, apply, which is off, intermittent operation. Okay, so you see that now what we've managed to do is we've managed to access the data in step 7. We've managed to draw it into the server. So having done this, this is just the third software we're talking about. Okay, now comes the interesting bit, the automation studio. Again, I already have a project set up, one which just has the preferences already configured. So open project. I think this has already been set. Okay, so this particular page is actually electrotechnical. Okay, so I need to zoom out to max because I've realized that's one way I get to have good visibility with the project element. The choice of document is electrotechnical default. Okay, I could have chosen electrotechnical NEMA or electrotechnical IEC, but here ni electrotechnical vechap. Now if you try shilomu, it's because of what? How do I show this to you? Okay, I'm going to go to in the project library explorer. Okay, this is just the library explorer. I'm going to go to where it says electrotechnical NEMA. Now the reason why I like using electrotechnical NEMA is because of the type of contacts. Okay, so relay contacts, I get to have them like so. Okay, so my point here is I need to configure a simple circuit. Okay, a simple control schematic. Okay, so I'm going to come in this library explorer, and then I'm going to look for power. Okay, let's see it. We have power. Okay, so power is right about there, and I need a three-phase power supply. Okay, do we get one with a neutral? Okay, let's get one with a neutral. So we get this one here. So what's the difference between this one here and this one? Okay, it says three-phase variable source. I don't particularly need a variable source. Okay, so we get this one here. This is our energy source. Okay, so having obtained our energy source like so, the only other thing we need is under protection. We need an isolator. We need a circuit breaker. Okay, so protections. We need a three-phase circuit breaker. Okay, circuit breaker 3-pole. We need this one here. Okay. Again, so now connection port names. Okay, let's pull them out a bit so that we have some sanity. Okay, so like this. Maybe slightly off, and then we're going to log the connection port names. Okay, so we've got the circuit breaker, and then right after this we can have the a rectifier. Okay, so let's go to power conversion. Okay, so where do we go from here? Power distribution, energy converters. Okay, energy converters, we need a rectifier. So we need a rectifier. Again, the same thing. So let's push them out. You don't have to, but I just feel I need to have clear labels. Okay, maybe we can push this down as rectifier 1. So we've got our rectifier, and then what else do we need? Got a rectifier, and then we could need a terminal block, okay, or a junction block if you want. It should be up top, lines and connections, junctions, and then we need maybe this one here. Okay, this is terminal block 1, and I feel we need another one for AC. Okay, so we need another one for AC, like so. So we have something like this. Okay, now when this is done, are we good to go? So the only thing we need to do now is to make the connections. Okay, so we're going to go to edit, to home, then polyphase wire, like so. Or maybe for the purpose of this control, because of this, I may need to use just a 2-phase. Okay, energy single phase. Apologies. We just use a single phase. Okay, so that then protections. I'll need a 2-pole breaker, not a 3-pole, but just. We're not having any 2-pole breaker. Anyway, we can change the breaker to the number of poles as just 2 poles. Okay, and then of course, whilst we're here, we can look at the voltage rating for this. Okay, so the maximum AC design voltage is 400, which is fine, so we won't bother changing any of these. We just leave them as default. Frequency is 60 Hertz. The minimum AC design voltage is 110 volts. Minimum frequency 40 volts. Okay, so this looks good, just like this. So we close this, and of course, what we have now is just this. Okay, this is what we have. So we have a single phase supply of 120 volts with a circuit breaker, and then we've got a rectifier. Okay, so we just need to make these connections like so, and then this is power line 1. Okay, so then this is a neutral wire, same as this other one. Okay, that's why I prefer to open this project, because I have everything configured the way I want. Okay, so now that we have this, the only other thing we need to do is, this is 120 volts. The only other DC I'll need is 24 volts. Okay, so we'll look at what this rectifier is rated for. So it's 208 to 180 volts. So what we need is 120 to 24 volts. Okay, so that's just about that. Okay, And if you wanted, you could also choose to see these. Okay, display alias, display value. So same thing with this other one, display alias, and then of course display value. So we can close this. So now what we have is the input voltage is 120 volts for this rectifier, right? And then the output voltage, of course, is 24 volts. Okay, that's what it says. And then of course I just need to connect the output to the terminal block. Okay, so I'm going to think of this as the positive supply terminal block. So I'm going to move it a bit to the left, because I'm also going to need a negative supply terminal block. So let me just move it a little bit like so, or maybe I should move this a little bit to the left so that we have everything in check. Okay, like so. Okay, so the negative end of the rectifier is going to come to this terminal block. Okay, maybe let's move this a little bit to the left like so. Maybe our rectifier can move a bit. So this is what we have. Okay, and then the same thing goes for the neutral. Okay, the same thing goes for the neutral block. So we assume this breaker is for the rectifier, and then we could also have maybe another breaker. Okay, we can have another breaker. Transformation, rotate right. The port name's free. Okay, so let's create a little bit of sanity with our okay. Okay, so this breaker is for the rectifier, and this breaker isolates the anyway. Is this the right way of doing this? Rectifier, this terminal block. Okay, doesn't really matter. We can use fuses or whatever, but so this will work for us. Okay, so we need 2 of these. So what we're calling the terminal block 2 is actually just the live terminal block. Okay, so I'm just going to do L, right? So this is live, and then this one here, I'm just going to think of this as the neutral block. Okay, item identifier, neutral block. Okay, and then for the terminal block where there's the positive polarity of the rectifier, this we can think of as maybe just M plus. Okay, like so. And then this other terminal block. Okay, so this other terminal block, we just think of this as M minus. Okay, so basically M plus is going to be the terminal block for the positive end of the voltage, M minus negative end. Okay, so the only thing we need to do now is this. Okay, is this. We're going to create jumpers across all the terminals of this terminal block. Okay, so jumper, Okay, I think that's just about does it. Oh, and then the same thing holds for this other end. So this is the live end, so I'm just going to like do this. And then this one here, okay, comes there, right? And this one here goes there. And then of course, I don't know why am I not really comfortable with this. Anyway, you can always move this a little bit down. Like so. And then as before, create jumpers. The jumper problem, okay? So basically when we do the jumpers, the only thing we need to do is we can simulate this, okay? Now our interest, of course, we're just going to close the breakers like so. So let's see, then we're going to check the voltages, okay? So it's supposed to be AC. Let's put one probe there, the other probe here, so it's 120. And then we can move to DC, put one probe there, one probe there, so we've got the 24 volts, okay? So put one probe there, put one probe there, it's 24 volts. So clearly the terminal block is 24 volts, okay, across. So we pick these probes, and then we go to AC, put one probe there. It doesn't really matter. Put one probe there, put one probe there. So what are we saying? So there, okay, there. Okay, so let's see here, there. Okay, they're not okay. Not okay. So these last two are not okay. So come on. So what we're saying is the last two and these three are not okay. So why are you not okay? So let's see. Let's, why am I struggling with this? Okay, and then so the last two, so let me just get rid of this, and then of course get rid of that. No, so jumper, so apparently I need to just do a horizontal, then just pull them up. Okay, need to just pull them up like so. Okay, so let's see if we've got any joy out of this. Okay, so DC, oh no, we need AC, so put one probe there, put the other probe here, close the breaker. Okay, so first position, second position, third, fourth, fifth, sixth. Okay, so these are fine. So second, third, fourth, fifth, and sixth. So that's fine. So now we move on to DC. So let's put this here, change to DC, put one probe there, reference this. So we need to close this. So these are fine also. So here, there, then the last one. So all the terminal blocks are fine. Okay, so now we're good to go with this. We don't have any issues with this. Okay, now the reason I'm showing you this is now we have a terminal block for 120, and then we also have a terminal block for 24 volts DC. Okay, now comes the interesting bit. Okay, in the library we have this part which is talking about PLC illustrated. Okay, PLC is illustrated version 1.4. I'm going to come to where it says Siemens, and then I'm going to come to where it says electrotechnical diagram, and then I'm going to pick on. So now this is basically our simulated PLC. Okay, so this is going to be our simulated PLC. So let me minimize it a bit. Oh, Control Z. Seems to have gotten some of our okay. Oh, come on. Okay, so the whole point is now we have this PLC, so we can even rename the PLC to what? To sample logic. Okay, that's what we're going to call this PLC, as just sample logic. Now I know if you look at this PLC is supposed to be powered by 120 volts AC, and the inputs are going to be needing like 24 volts DC, which accounts for our live 120 volts block and then the 24 volts DC. Okay, so here I could just as easily have done this. Okay, could just as easily have done this. I could have done this. Okay, I could have done this. There would totally be nothing wrong with this. I could just run wires from the terminal blocks to where they're needed. Okay, like I could just do this. But this is kind of, I don't like the, okay, there's nothing wrong with it, but in a way I would rather not do this. And I think maybe it will be of benefit for me to show you how we can also do this. We're going to come back to the library explorer twalaisa papa dati electrotechnical mulamwino twachiwa muri electrotechnical. So twalaisa muri electrotechnical, which is this one, electrotechnical NEMA, and then we're going to come down under lines and connections to where it says links. Okay, so to start with, we need a 120 volt supply to the PLC. Okay, but before that we need a ground. Okay, so we need to have a ground, so this we can just as easily get out of the way. Okay, so this is our ground or our earthing point. So this is ground, power ground wire, and then after that we go into the business of the power supply. So 120 def. So I'm going to say come to where it says electrotechnical NEMA, under lines and connections. I'm going to go to where it says terminals, then links. Okay, I'm going to look for output link, where it says output link. Okay, I'm going to get this one here. An output link is clearly just a reference. Okay, it's clearly just a reference. So this one I'm going to call, this is L, I'm going to call this as L1. Okay, so L1, okay, done. Data, internal item identifier, this is going to be L1 also. So like this is our L1. Now where this L1 is an output link, so to associate it with an input, I need to come to where it says single pole input link. Okay, so I'm going to pick this one here, then I'm going to put it on L1. Okay, so this one I'm going to associate it with L1, right? So just double click on this one here, then go to data, under item identifier. Of course this is just L1. Okay, this is just L1. Then I can even pull this up a bit, okay, so that it's really neat. Okay, so that you can actually appreciate what we're trying to, so that you appreciate what we're trying to achieve. Okay, so this is L1, and then for the neutral, I'm going to come to the neutral block. Okay, I'm going to need another output link. Okay, so I'm going to double click on this, then this is going to be N1. Okay, I'm going to come to data, I'm going to call this as N1, like so, and then I'm going to need another input link. Okay, so I'm just going to copy this. I'm just going to copy this to that position, and then for associations, I don't know why is this being troublesome moving. Okay, so I'm just going to maybe just double click on this, left double click, association, I'm going to associate it with N1, then data, I'm going to change the item identifier to N1. Okay, like so, and then I'm just going to close this. But I'm not really comfortable, or maybe should I transformation rotate left, transformation rotate left, then maybe move it up a bit. Why am I struggling with this? So 120, so that I'm able to have those smooth movements. Okay, I think this pretty much looks okay, like this. So N1, L1 is associated to this one, N1 is associated to that one there. Okay, so this, we do the same thing with the DC supply. Okay, where it says L plus and M, right? So L plus, we're going to get from the terminal block, the positive polarity of this. Okay, so of course we're going to need an output link. Okay, going to need an output link, two output links, one for the positive terminal block, one for the negative terminal block. Okay, this one, left double click, association, I'm going to call this as M plus 1, or rather just maybe 1M plus. So 1M plus. Okay, so data, this is 1M plus. Okay, so this is 1M plus, and then of course I can just copy this input link. Okay, I can just copy it to L plus as an input terminal for the PLC, and then I'm going to associate this to 1M plus. Okay, so association associated to 1M plus. Okay, data, I'm going to call this as 1M plus. Okay, that takes care of that association. Okay, and then thereafter I'll need a negative polarity. Okay, because this is like plus 24 volts minus 24 volts, that kind of thing. So I'm going to copy this input link again to the negative terminal of the input. Okay, and then of course I'm going to copy this, or rather I'm just going to define this as okay, so double click, left double click, and then I'm going to call this as 1M minus. Okay, 1M minus, data, item identifier, so it's going to be 1M minus, like this. Okay, so 1M minus, and then I'm going to associate this input link to 1M minus. Okay, so left double click, association 1M minus. Okay, then data, I need to change the internal item identifier to 1M minus. No, 1M minus, like so. So this association is made. Okay, so these are satisfied, and then across these two terminals, okay, between these two terminals, I'm just going to do like a jumper, because now we know how to put jumpers. Okay, going to put jumpers, then I can just draw this up like so. So the jumper is done, and then I think that's just about it. And then what else do we need for inputs, right? For an input, we go to where it says switches under electrotechnical NEMA. Okay, so it should be under control, then switches. So switches, I'll need a normally open push button and a normally closed one. Okay, so transformation, rotate left. I'm going to put it right about there. We might as well. Okay, so let's see, port names, I need them free. This is just S1. I need to connect this point to here, to the input. Okay, so let's see, can I move this a bit? I need to have Okay, that's just good enough, like so. Then transformation, rotate left, like so. Need to maybe stagger these a bit because of the space. Okay, so maybe move this, I don't know. So connection log, connection port names, I need them free. This is our S2. Okay, so this is S1, this is S2. You notice that this push button is essentially in the closed position. This one is in the open position. Okay, so let's see the. So can I move this a little bit down? Can I move this safely down? Okay, let's see. Okay, so now we have this. Okay, so now that we have this is a start push button, stop push button, and then you notice that all we need is to provide a positive voltage on this end. Okay, again, I could just as well take the, I can just as well put a jumper, or I can just draw something like this. Okay, I could do something like this. This would work, but anyway, you could say I'm being biased, but let's see if I move this a little bit. That's, you know, that's the reason why I don't really like crossing wires. Okay, the whole point is that we need a positive polarity at on the input side of the input conditions. Okay, so I can just as well add another output link. Okay, and then this one I'm going to call L2, right? This one I'm going to call L2, and then of course this is just L2. So this is L2. Now you notice that it's not underlined or underscored because it's not linked to anything at the moment. Okay, so the only thing is we need to copy this input link, then put it right about there. Then we're going to link this to L2. Okay, we're going to link this to L2. In data, item ID, we're going to call this as L2. Now it's underscored because it's actually associated. It's linked rather. So the only thing I need to do now is make the connection to that point, and then do something like this. Okay. I think that's just about does it. Could we have done better? Oh, okay. Okay, let me get rid of this, or rather let me just move this a bit here. Okay, so I think that's better. This is better. Okay. Okay, so the only thing I'm saying is L2. What am I doing? No, sorry, I do apologize. Okay, I do deeply apologize. Okay, I can just, anyway, I can just move this. I can move this here. I can move it here. Okay, transformation. Anyway, not really. Okay, let's see. Transformation. Rotate left. And then I'm going to rename this to 1M plus. Okay, sorry about that. I'm going to rename this as 1m plus. Okay, this is 1m plus. Transformation, rotate left. Okay. 1m plus. What is wrong with you? I must be getting very sleepy now. Must be getting very sleepy. This is 2m plus, right? And then let's get rid of this because I don't want to start. Control Z. I just need to okay, so this is 2m plus. Okay, so this takes care of that. Okay, so this is 1m plus, 2m plus, 1m plus. So this is 1m plus, positive supply. 2m plus is used in this position. Okay, now 1m plus, 2m plus, wherever you see m plus, is just the positive end of the rectifier supply. Okay, so to prove a point, we can just put this in the run. Okay, so we can close the breaker and then just measure the voltages on the terminals. Okay, so we can measure here across like so, which is 24, right? Then we can measure between this point and that point, which is also 24. So this is just okay. So that takes care of that little experiment. Okay, what am I not seeing? Oh, because the PLC wasn't powered. So this is okay. So if we do this, so we've got a response. Okay, so this is what we get to have. So the only other thing is we've dealt with the input side. Okay, so now we go to the output side. Again, on the output side, the output coil will need 120 volts AC. Okay, so we will need to do line 1. We need 1L and 2L. Okay, so 1L and 2L, we'll copy this, okay, to the second position, and then this will go L2, right? Oh, because we did, okay, I don't know, I don't want to jinx it. I don't know what it is we've messed up, but anyway, I'll call this as L3. So because L2 was renamed to another position, I'm sure that's why there's that conflict. I was supposed to have come in here and deleted it, but for as long as it works, right? So this is L3. Data, I'm going to change this to L3. Okay, it's done. It's not linked, so it's not underscored. Okay, so this is an output link. Then we'll need an input link. So let's copy this. Like so. Flip. Okay, like this. So this now is going to be the live input. Input link. Okay, so this will be linked to L1. So this is our input link, and it's going to be associated with L3. Okay, it's going to be associated with L3. So let's double click on this association L3, double click, left double click, data, we need to change the item identifier to L3. Okay, so we just close that, so it's linked because this now is underscored. Okay, again here L1 same as L2, but we can just as well do a jumper across. Okay, if we didn't want to do a jumper, we can create another input link, in which case we can just come here, copy this output link to the next, oh come on, to the next available slot, like so. This is going to be L4. Item identifier L4. Okay, it's not linked, it's not underscored, so we come here, we'll copy this, maybe just this. Okay, and then we just connect, and then we're going to link this to L4. Okay, you left double click, and then you change the item identifier to L4, just so you know what you're linking. Okay, so this is done, and then having done this, the only thing we need is an output coil. Okay, we need an output coil. So let's see, contactor coils or relay coils, whichever, doesn't really matter anyway. So let's go with relay coil. And this relay coil, what's the control voltage? Builder, let's see what your voltage is. So this is 120 volts, okay, which is convenient. Frequency 60 Hz, won't change anything. Okay, so we will just transformation, rotate left, and then this transformation, rotate left, come there. This is going to be our output coil. Okay, maybe, what do I need? Maybe I could move this up like so, because I don't really have anything to do with this. Okay, so we can move them up a bit like this. Okay, so that now the output coil will be here. Okay, so the output coil will link to this. Okay, so maybe we can just move it a little bit to the right, a little bit again maybe. This is not really, I don't know, I just would have loved it to be perfectly aligned. Okay, apparently that is not to be so. So anyway, so this is the first output we are assigning, right? So for this to work, we just need to have a neutral end connected to this point. Okay, so that said, we just go to the neutral block. We'll copy this output link, and then we'll call this as N2, right? We'll call this as N2. Okay, like so. Data, this becomes N2. And then we'll need an input link. So we'll copy this one, we'll put it there. So this one will link to N2. Okay, we'll come and link to N2. So just to show us that this is actually N2. We rename this to N2. Okay. So this clearly does it pretty much meets the configuration, the one we have in step 7. Okay. Maybe let me just move this up a bit. So let's delete that. Let's move you up a bit. Okay. So this is exactly the configuration that we have in step 7. Okay. So now the only thing we're going to do is we're going to save. It's always a good thing to save. And then when we do save, we're going to do some configuration. Okay. So we're going to come up here to where it says communication. Is it tools? Yes, tools, then communication manager. Okay. Now, if you're doing this, like we created our project, which was I think plant 007. I've already added the Kepware server in Automation Studio, right? So I'm going to come to where it says plant, and let's see, OPC, then groups, plant 005. This is no longer there, so I'm going to add a group, and then I'm going to call this as plant 007, in which server? Plant. Okay, so the server I added as Kep server, I called this as plant, so which is why it's here. Okay, this is just Kep server. Okay, this is just the symbolic name for Kep server in Automation Studio. So I'm just going to say okay. Then I'm going to say go to where it says links. Okay, in which group? Plant 007, and then I'm going to scroll down here. Okay, this is exactly the interface for Kep server. Okay, let me do this. If you look at this, okay, this is essentially just browsing whatever is in Kep server. This is plant 007, which is down here. This is plant 007. It's in Kep server. Okay, so minimize this. So open this, explore, go down. So we have the start, stop, and run. Okay, so on the left side we have input 0.0, which is going to be linked to the start. Okay, the flow of data is that the Automation Studio is supposed to write to the OPC. Okay, so which is in this direction. So create this, and the next one is input 0.1 for the stop. So this is linked to stop with the same flow of information. Automation Studio to the OPC, then create. Then for the output address, which is Q0.0, is going to be linked to the run. Okay, the flow of information is such that the OPC, OPC is supposed to write to Automation Studio. So create that. Okay. So we're done. In this, we're done. So the only thing we need to do is run. Okay. So now that we're running, we need to close the breakers for the rectifier, and then the live AC for control. Okay. So rectifier closed, energized, and the AC for control, or rather for the supply of the PLC, has also been closed, the breakers. Okay. So now we have this. So I'm going to put this next to step 7. Okay, I'm going to put them side by side, like so. Won't be needing that. So this is what we have. Okay. So you see already that the Automation Studio is already communicating with the semantic step 7. Okay. So if I did press start, the system is able to start. Okay. If I did press stop, the system stops. Okay. Start, system starts. Stop, system stops. Okay. So clearly what you have seen in this regard is that we're able to use Automation Studio to work together with semantic step 7. Inombe area bebati the possibilities are endless, because now we can take almost any configuration that we have. Titwabola fechi electrical control schematic, tuamona pa ama inputs niesa ama outputs niesa, tuadonsela mona ka PLC ngefine tuchitirefi. Then tuachita assign ama inputs, tuachita assign ama outputs, then we create our logic mudi step 7, so that now we're able to simulate basically almost anything that you can think of. Okay, so hopefully if ifyala miafwa ko kuishibati na automation studio ine titwayo mfya kudi mukusambidila ama PLC, because yala tupela environment uma tuingapanga ama input conditions yonse or tulefwa na inachila milange hii ama links. It's not necessary that you need to reference ama links like this. It's only that like this it looks neat. I mean, just look at this, it's neat, right? You could also have chosen to just draw IFMA lines from this terminal block to where you need the supply, this terminal block where you need the supply, but it would be a whole lot of mess. Okay, but this is neat. Okay, so desubila ififyala miafwa ko palwendo lwenu lwa kusambirila ama PLC design. So kalebarika.